Okay, so here we go with the last one, shooting off of a cliff. All right, and what we're going to do, like I said last time, is we're going to be interested in is this thing when it hits the ground right here. Okay, what's the speed at which it hits the ground? Okay, now the way we're going to go about this is we're going to, let me come over here. We're going to say, let's suppose this is the vector. All right, and it hits the ground, and it's going to have some final velocity. Okay, just like that. And so what we're going to have to do to get that is figure out the v final x and the v final y. Okay, so if we can get the v final x and the v final y, then v final is just going to be square root v final x squared plus v final y squared, just like that. And then the angle, okay, so look here, here's our angle right there. Okay, so our angle, we could say that the tangent of theta is just going to be v final y over v final x. We'll just use a rise over run. Okay, and when we do that, we'll use magnitudes. Okay, so we don't care about that. Okay, so how do we get v final x? Well, v final x is the same thing as v original x right up here. Okay, so v final x is just going to be v naught x, which in our case was 3759. Okay, because in our model that horizontal aspect of the velocity isn't going to change. Okay, then how do we get the vy final? Well, for that one, what we'll actually do is we'll use SAM. Okay, v final y is v original y, so v final is v initial minus a, plus a delta t. Okay, so if we had the time of flight, then we could pop that right out of there. Now, we already worked this out and found that our time of flight, our delta t, I didn't get that written down up here, our delta t on this from before was 3.848. Like so, okay, 3.848. Okay, and so then all we have to do is plug in our numbers. V naught y, it was going upwards, so 13.68 meters per second minus g, which is 9.81. Remember, g is positive, meters per second squared, and our time of flight is 3.848 seconds. Check our units real quick. Okay, we got meters per second over here. Meters per second squared, one of those cancels one of those. So we're left overall with meters per second. Nice. Okay, and VF. Y is going to become 44.6 with 3 sig figs. Meters per second. Okay. So then if I take my value here and here, plug, oops, that went there. That's the wrong way. I want to plug it in there. Plug this guy in over here. Plug that one in over here. What I'm going to get for my V final then, my final velocity is, oops. Gotta go back. Sorry, a little tedious here. I copied wrong off of my paper. V final F is minus 24.07. Okay, because it's headed down. Okay, it's headed down just like that, and that's meters per second. Okay, then if I take this guy, plug it up in here, and I take this guy, plug it in over there, then what I'm going to get for my final velocity is 44.6 meters per second. Okay, so that's my speed. And then if I plug in things for my numbers here and stay with magnitudes, 24.07 divided by 3759. Okay, what we learn is that our angle is 32.6. Okay, degrees. Okay, so I can use that information about the speed to get the final speed, the impact speed, plus the angle of the impact. Okay, there we go. So those are some really common things, those 4 videos. Okay, now I'm going to do 2 more videos. All right, just sort of illustrating a few additional things for you. Okay, and anyway, so let's get on with it.